1 minute over. 1 minute over. Is voice clear? Voice clear now? Setting is okay. Fast answer. See that I don't, that earlier how it happened repeats once again. Already 5 minutes over. This will remove. I started now. Fully audible? Voice fully audible? Display is okay, I think. You can see everything. I won't wait too much time now. Voice clear? Okay. Okay, start. See. Last time we considered users buckling code. One small information for you. Small information. I am back in Bangalore now. Is the display also very clear now compared to what happened on that day? Is the display is clear now? Last week I took in native place 1 class. Is the display fully clear? Okay. So this is today's class number. What is one called? See, today's class is BSK Class 194 and that class number 4, I think, correct? Is it 4? For columns. Main class is BSK 194. For column it is 4, correct? No, for column it is 4, I think. 4 or 5. Today's class. You can see in the, I cannot check now because I have to go to, I think columns and struts 1, 2, 3 over. This is 4, I think, most probably. Is it 4 correct? Is that 4 correct? For columns. I think it is 4. Otherwise, I have to leave this one and go there and check it. You have seen in the thumbnail you have seen class number for columns. 4, okay. Now, BSK, this is today's class. See, this is today's class, no problem. Today's class. Absolutely no problem. It will start now. Previous class. previous class, that is BSK class 193 and column class number 3, even I saw after the class, nothing was visible, full blur only. Yes or no? Was it fully blur? Voice was okay. That previous class, fully blur. You can only hear the voice. Screen was, you can't make out what's there. Yes or no? Because there was net problem. I think previous class was fully blur. Blur means what? You can't make out anything. It will be difficult to study. Yes or no? Okay. Actually, same thing happened next day when I took that, I don't know which class I took. One ETAP class I taken. One Saturday successfully, no problem. Sunday class, there was a problem. Halfway through, I stopped the class. Because there, weather problem, network problem. Okay, now, most probably tomorrow itself, before your class, this I will retake this class BSK 193 and column 3, I will put title there. BSK 193, some title I will put here. So that is all the explanation I had done last time. I will just go through the video there and see what all I told. In the paper, I will make a note. I will make a note what all I told. Then here I will record and give it. I won't take live. Because my voice was there. I given some examples there. See, suppose in that class I gave examples regarding some money matter or etc. That I may not tell. But concept wise, this class I will record. See, that was actually 1.5 hours. I think it takes only some 45 minutes class. So this 45 minutes, tomorrow I will upload. Clear? I will upload tomorrow so that everything I told there, that slenderness ratio, that modified formula, what all I told there, I will make it. Here, net problem is, I am back in Bangalore now. There is no net problem now. So tomorrow I will record and update it, upload it. Okay, tomorrow I will upload it. Most probably tomorrow, worst come worst day of tomorrow. Okay. Now, leave now. Anisha, it's paper. Usual problem for paper. Okay, here. Okay, now start today's class. See, in the title I written limitations of Euler's formula. But before starting limitation, one example and then I start. See, one important example. Example. To understand thoroughly, right here. Important example to understand thoroughly limitation, you write here. To understand thoroughly limitations of Euler's formula or Euler's theory, it has got limitations. See, every column Euler's formula is not applicable. It is conditional. So you cannot apply randomly for any column. You can't apply Euler's load, Euler's buckling load expression and tell column will buckle at this load. No, you can't do it. So for that one, important example, you write here. Now see. Consider a column. Last time, one simple example I given, it was rectangular section. Sufficient. Now see. Now, consider a column, or I'll do one thing, I'll write here. So that it is a common data here. 1 minute. So that I can write that side, I can use common data here. 1 minute. I'll see up to where there is no problem. Today I think almost full board is there. Yes, up to here no problem today. Because I put a wide screen today. Today I put a wide screen. Oh, yes, okay. Furthermore I can go. Okay. Up to here. Up to there I can write. Okay. Still space is there. Okay, leave it. So I will write question here. See. This important example I will write here. Question. See. Consider a column because that side I want for working, for understanding everything, I want that side. Or okay, no problem. I can write here only. Nothing to worry. See. So that I can work out this side. Consider a column. Of, instead of rectangular section, I will take hollow circular section. Remember, hollow circular section or cylindrical section, or you can tell pipe. Some people call hollow circular section, some people call hollow cylindrical section, sometimes people call pipe. Okay, hollow circular section of outer diameter 150 millimeter and thickness 10 millimeter. Now next, I won't give end condition today because directly I will give effective length. Next, see, very important, crushing strength or crushing stress for material. I am not telling what material. Most probably such questions, when pipes are used, it is usually steel pipe. Okay, nothing to worry. Crushing stress for the material is 330 MPa. That is actually for steel. And modulus of elasticity is 200 GPa. That is, now you are sure it is steel. 1 minute. When you apply Euler's formula, do you require crushing strength? Tell me. Pi square, they got option. Pi square EI by L effective square, direct formula, or modified version, pi square EA by lambda square. Is crushing stress comes anywhere there? Does the crushing stress comes anywhere there? Tell me. No. Does the crushing stress comes anywhere there? Oh, that no you are given just now answer. I don't, it was earlier no, I think. Because so fast answer will not come. When I came here, I can see a no there. It was a previous no. See, when I write a formula, pi square EI by L effective square, that is the original formula. Or pi square EA by lambda square. That is covered in previous class. But that was only not clear. I will write once again. Okay, leave it. No, it will not come. Still it is written. See, crushing stress for the material, remember, does not come in Euler's formula. Right here. This does not come in Euler's formula. That's all. Still given. Why? Wait for some time. Wait. Then, this is the property now. Now, find Euler's buckling load. Find Euler's buckling load for following three cases. I will put here. The cases, I will put red color for the reason. See, this is a common data, but following three cases, it is different cases. I will use red color so that you can make out why following three cases. Yes, got the red color, fortunately. Case 1. Effective length. I am not giving actual length because if actual length given, finally it has to be converted to effective length. So why we should waste time? If they give actual length and end conditions, using that you convert to effective length. So to discuss something, we always require effective length. No discussion is made based on actual length. So case 1, effective length equal to some meter. Case 2, same effective length equal to some other meter. Case 3, same effective length equal to some other meter. Now, I will give little later, not now. Value I want to give so that, I will give the value so that it will match with the result. That's why right now not giving. Actually, it is actually given. I am not giving because I want a range, one upper range, one lower range, one intermediate range I want. So, time being pending. Otherwise, I will take my calculator, do something and then calculate. Why? It will come now. Okay, leave it now. Or, remember now, here length is smaller. For this one, effective length is bigger. Here, I'll tell you. What is the meaning? I'll tell you here. Here, effective something means the column is quite bigger. See, quite bigger. Here column is little shorter. Here column is very, very short. I am not putting end conditions. Why? We don't know end conditions. Here see bigger, here medium, here smaller. That is the purpose. Okay, start. Now, solution. So, first common data. First common data. First common part. Tell the formula. Euler's buckling load. See, we will not hurry today because why? Important concept. Euler's buckling load. That is, symbol is PB equal to, you can use either pi square EI by L effective square is original formula. This is original or derived. Or you can write PB equal to pi square EA by lambda square. Pi square EA by lambda square. Both are same. Clear? Both are same. This is we have done in the class number 3. Unfortunately, quality was not good, so I will upload once again. But you know it already. See, I will tell you easiest way. Once again I will tell. Or 1 minute here. We are discussing in strength of materials when effective length is same with respect to both the axes. Very important. This is now here common data. E is modulus of elasticity. Modulus of elasticity of material. Of material. Therefore, your E equal to, and one thing, when you solve in Newton and millimeter. Remember, units are important. Okay, this is the unit you are solving. E equal to how much? 200 GPa or equal to 210 to the power 3 MPa. You know that MPa is Newton per mm square over E over. Then L effective is effective length. I write everything. L effective is effective length. Effective length of column based on actual length and end condition. This is already told last time, earlier class also. Tomorrow, in the previous class, when I retake the class or when I record it, once again I take the class, I will explain once again. Okay, now I told 1000 times. I is, this I told, see, sometimes people are there who will tell, sir, you cannot take always least I. Sometimes one axis has got lesser I, other axis has got higher I. Still, higher I count sometimes. I will tell them, I know it. RCC all have done it. Steel also have done it. That is when L effective changes for the axis. Sometimes higher I, but huge effective length for in that plane. Means even though I is more, L effective by R will become higher then. So you cannot tell. But in strength of materials, we don't discuss those things. Whether buckling is this way or buckling is this way, effective length is same. This I told earlier. Strength of materials, we don't discuss those things all. There's a limitation. I cannot, because some people, if I tell all those things, they will tell, he is telling something which I never heard so far. That comes in RCC steel. Remember, in RCC steel, I told everything, yes or no. In RCC steel, I told very clearly about effective length with respect to this side, with respect to this side all. Yes or no, tell me. In RCC class and steel class, what is effective length? If you take this side, what is effective length? If you take other side all. Or when you consider XX or YY axis, how to consider effective length? So it comes in applied subject. In strength of, I told, strength of materials, we don't bother. L effective same with respect to both axes. So I is very important. Least moment of inertia, red color because why important? Least moment of inertia of cross section. Okay. Now, if I see this formula, that's all you require. See, pi square EI by L effective square. But if I go to that formula, 1 minute now. If you want that formula, once again, see, you start this formula. PB equal to pi square EI by L effective square, or equal to pi square E. I you can write AR square. This I will not tell once again. You know I equal to AR square divided by L effective square, or pi square E into A divided by L effective by R whole square. See, this will come denominator, whole square. L effective by R is called slenderness ratio lambda. Then your formula becomes pi square EA by lambda square. Clear? Actually, this is the original formula. This is what? This is original. This is modified but more powerful. More powerful. Remember, this is the most powerful. Which one? The modified formula is more powerful. We will apply both of them now. Don't worry. Okay. This much clear? Now, if I go to that formula, then I have to continue. A is cross-sectional area. A is cross-sectional area. Okay, then lambda comes. Lambda is slenderness ratio. Slenderness ratio. Regarding the slenderness ratio, lambda higher, lambda lesser, what happens? That all I discussed in previous class, but since quality is not good, I am uploading once again, don't worry. Within 1 or 2 days, you will get it. And formula for lambda is what? Lambda equal to, it is the ratio of effective length to least radius of gyration of cross section, R minimum. Then further, where your R minimum is root of I minimum by area. These all I told earlier. So now, time being, fully clear? These statements, formulas all, fully clear? First tell me. The statement, etc., fully clear? The statement and expressions all, fully clear? See, today we are discussing important property of Euler's, important property or limitations of Euler's formula. This much clear? First, clear. Okay. Now, start. Now, for our column, see, now I will do one thing now. I will continue once again. See, this effective length, I will tell you little later. See, now cut from here, you continue here. Okay, start. Cross section you write. L effective, there are 3 questions are there. Don't worry now. Your cross section is hollow circular section this way. This is the column cross section. Outer diameter is 150 millimeter. Thickness is 10 millimeter. All dimensions in millimeter. Therefore, outer I can take D1. So project here. This will become your D2. D2. Tell the D2 value. Tell the D2 value. So those who want write, D1 is the out. You should write. Why should I write here? I am dictating. Hollow circular section. D1 is the outer dia. D2 is the inner dia. Thickness is 10 mm here. So outer 150, how much is D2? If I show the calculation, some should leave the class and tell your class you are not coming. You are wasting time for such a elementary thing. D2, how much? D2 130. Someone will tell, sir, not clear. Let it be not clear only, better. When outer is 150, this is 10, this is 10. How inner came 130? If not clear, let it be not clear only. Okay, now start. If I want this formula, I need I minimum. Remember, for a hollow, for a square section or circular section, solid circular section or hollow circular section or some sections, what happens is, irrespective of orientation, I about any axis is constant. See, if I call this as YY axis, if I call this as XX axis, no effect. See, your I above, see, you can make a note here. Here, area equal to pi by 4 of outer dia square minus inner dia square. Okay, then I about any axis need not be here, even this way also, any axis but passing through CG, right here. Some will tell about this axis not same. I will tell them, talk sense. We are discussing I is the moment of inertia about the centroidal axis. Basic bending theory is there. You are using basic bending theory. Do not unnecessarily tell things which you know little more. Little you are knowing, don't try to tell me. I know much better. I will show how much I know. I told I about any, not applicable for any of you, not applicable for any of you, only for those troublemakers, otherwise not applicable. You, those who are in the BSK batch, you will not tell that I know it. You, none of my comments are applicable for you. Okay. I about any axis equal to pi by 64 into, actually circular section is pi d power 4 by 64 hollow into d1 power 4 minus d2 power 4 is I. So with that data, if I use this formula, I need only I. So your I minimum equal to pi by 64 into 150 power 4 minus 130 power 4. Tell the answer in 10 to the power 6 millimeter power 4. Fast answer. Tell the answer in 10 to the power 6 millimeter power 4. My calculator I kept somewhere. I don't know where is my calculator. I not bought here, I think, or is it inside? Where I kept my calculator? Because after coming from native place, this is the first class today. I think calculator is not here. You should tell, but I need my calculator because I need my calculator. 10.831 10 to the power 6. Okay, thank you. 10.831 10 to the power 6. Okay. This data I see now. Pi is known, E is known, I is known, L effective known, 3 parameters are there. Therefore, now if I use the direct original formula, data is sufficient to find buckling load. Tell yes or no. With this much data, you can apply the basic formula and find buckling load. Tell yes or no. With this much data, okay, minimum or I'll come. No, this much data is sufficient if you apply basic formula. Tell yes or no. You don't require R. Actually, R is inside. Tell yes or no. You don't require the value of R now. Because see the basic formula. Pi square EI by L effective square. Therefore, this data is sufficient if you use original formula. Just tell me yes or no. There's a reason. Reason for asking. You have to answer yes or no. I am searching for my calculator by that time. Because calculator required for me. 1 minute. Where is my calculator? You are not answering. By not answering, you are giving time for me to search for the calculator. Hello, ito calculator na. Where I kept it? It was here. It is not here. See, you are not answering anything. 1 minute. If basic formula is used, this much data is sufficient. 1 minute. Anyway, I need the calculator because while setting effective length, I have to use the calculator. Just a minute. You are not, still you are not answering. This much data is sufficient if you apply basic formula. Tell yes or no. See, why I am asking? Because I should confirm. See, some will ask you, it is correct. Why you want to ask a question? Reason I told you. I want to confirm that audio is clear. For that reason I am asking. Sometime I am expecting a reply to ensure that audio is fully clear. That's why I am asking. Till you are not replying. So I will keep quiet. Till you reply, I will keep quiet. What to do? So 2 reasons are there. 1, audio is not clear. If audio is not clear, there is no point in continuing the class. Second reason, those who are present has left the class. Then also I stop the class. At least there should be 1 person attending the class. See, Still you are not, you told R minimum. I didn't ask it. I asked the question. This much data is sufficient if you use the original formula. You are still not answering. Yes or no I want. Some answer. This is to purpose is what? Purpose is to confirm audio, not time pass. Some will tell. You can make out here only. Why he is asking question? Purpose is to confirm audio is clear once in a while. This much data is sufficient if you use original formula. This formula. This data not required. I told I wrote already E here. L-petty I am giving. L-petty I am giving. This much data is not required. I is not required. What is this? I is not required. I is not required. Then how you are solving? I don't understand. What is I is not required? This data is not required means what data? See? Which data? This data is not required means which data? That's why I told. This much data is sufficient if you are using original formula. Yes or no? No, you are telling yes or no. This much data is sufficient. This much calculation part is sufficient if you are using the original formula. That's all I want. Yes or no. That's all. You don't have to tell not required. Yes or no I want. That's all. You require data. Still see, no answer. I am not asking which are not required. I told this much data is sufficient or this much values are sufficient to apply original formula. Answer should be yes or no. Yes, that's all. See, simple question. Over. Now, but see, one line right here. Now only. Make a note. You make a note. Suppose you write here. This formula. Suppose you are finding buckling load by this formula. Write it here. Data is sufficient. But I do not want to once again go there. So, suppose I want to use the second formula, which is modified. Some will ask, why you are using? Because this is more powerful than this one. This is, here the L effective square is there. R square is there here. It has come denominator. Technically, this is more powerful. Clear? This is more powerful and this is the real formula. Technically or concept point of view, this is important. Therefore, write here. But if you use the modified version, that is the real concept-wise formula, then you require area and lambda. Start. Now only start. Area equal to pi by 4 of 150 square minus 130 square. Can you tell me area in millimeter square? Fast. Area in millimeter square. How much? Pi by 4 of, you are not giving answer. Is the area 4398, third decimal sufficient, 98.230. Is the area correct? 4398, okay, over. Area over. Then you also require lambda equal to L effective by R minimum. Find R minimum. And see, R minimum equal to square root of I minimum 10.831 10 to the power 6 divided by 4398.230. Tell the R minimum in millimeter. Why? It is the radius of gyration. Millimeter power 4 by millimeter square is millimeter square. Root will give millimeter. Or you can make out here. Radius, it's a linear term. What is R minimum? Into. Is it 49.624? Correct? 49.624. Or to make more accurately, 6244 for more accuracy. 6244 millimeter. Therefore, lambda you can't calculate. Why? L effective pending. Over. See, now Start. Start. Case 1. I will solve one by one. Case 1. Just one important question to ask those who are concept based. If column is solid circular section, I told you what is R minimum. Anybody can tell? If the column is solid circular section, see, of diameter D, then I equal to pi d power 4 by 64. A equal to pi d square by 4. So your R becomes root of pi d power 4 by 64 divided by pi d square by 4, or pi cancels, d square by d square, d power 4 by d square is d square root d, 64 by 4 is 16, it will become d by 4. Yes or no? Your R will become d by 4. Clear? If it's solid circular section, R will come d by 4. Is a standard answer. Like for rectangle, I told shorter side by root 12. That way, circular section, solid circular section, R equal to d by 4. Okay, this I will discuss later. Now, d by 4 means, see, here, outer die is 150. Tell what is 150 power 4? If it is a solid circular section of diameter 150, your R will be 150 by 4. 150 by 4, how much? If it is not hollow, suppose it is a solid circular section of diameter 150, inner part is solid. How much? 150 power 4. 150 by 4. What power 4? 150 by 4. 150 divided by 4. What is the answer? 150 by 4. 37.5 millimeter. See, if it is solid circular section, for this diameter of 150 mm, your R will be 37.5 millimeter. But here, because of hollow section, your R became how much? 49.624. Tell me, good or bad? So, good or bad? Your R increased from 37.5 to 49.624. Good or bad? I told long back, area, moment of inertia, radius of gyration, section modulus, they are all strength supporting factors. So, your area, everything are strength supporting factors. So, good or bad? Answer. Good. Anybody can tell the reason why R increased? Simple question. Logically, not by telling formula all. Why R increased? The moment you make, see, solid section, R will be d by 4. The moment you make hollow, even if you remove little portion here, even then 37.5 will become 38.5. Remove little more, 37.5 may become some 42.5, that way. So finally it reached 49.624. Reason can be told, or this will tell you, tell me now. Now you can decide to prevent buckling, hollow is better or solid is better. With a constant area. Solid better, yes, it is dispersion. Earlier it was all see, everywhere area is here. Here area is dispersed at more distance from center compared to the inner area. These all I explained in CGMI chapter. Yes or no? No. This all I explained in CGMI chapter with plenty of examples also. That is the real meaning of R. It is not simply root of I by A. What is the real meaning of R? If you remember in what CGMI chapter, I told very clearly what is the concept of R. By shifting the dispersion, I explained very thoroughly. Tell yes or no? Long back. In CGMI chapter, I discussed about R and made the concept completely clear. Remember it? Some of you agreed. It is a very nice example regarding dispersion. But yes or no? I told all the concept of R there. Why R increases, etc., etc. But here, in this YouTube class for columns, that's all I can tell. Some will tell that also. No, if I keep on telling that way, there will be no limit. Okay, now, R also clear. Okay, now, tell me, case 1. Case 1 is your effective length, that is L effective equal to, I will tell you effective length now. 1 minute. I will tell you effective length. With huge effective length actually. See, case 1 effective length is very huge. 16 meter, very huge length. Like a pole, electric or some pipe pole, effective length is 16 meter, very huge. Case 2 is 4.2 meter. Case 2. Case 3 is small pipe of effective length equal to only 0.4 meter. See, that's all, this much. One first question, 16 meter. Maybe it's a fixed at base and free at the top, length may be 8 meter, effective becomes 2 times L, becomes 6 meter. You can tilt that way. Maybe case 1, I can take the fixed and free end also. You can make a note. Maybe this column you imagine for understanding purpose, base fixed, top free. Case 1, maybe length 8 meter. If length is 8 meter, L effective becomes 2L, becomes 16 meter. Case 2, somewhat medium, see, 2.1 meter. Human height, around little more than human height. This way, pipe section. Length is 2.1 meter. When you convert to effective length, becomes 4.2 meter. Case 3, very small. Length is only 0.2 meter, not even 1 feet. Around how much? 8 inches. But when you convert to effective length, becomes double, that is 0.4. You never bother end conditions. You take the question, effective length. So case 1 is L effective equal to 16 meter. Okay, now 16 meter. Or I told you, you should not substitute meter. We decided all substitutions in newtons millimeter equal to 16,000 millimeter. Therefore, if we use basic formula, buckling load PB equal to pi square into E. See, I'll put formula. Basic formula, buckling load, pi square EI, I'll put somewhere here. Okay, if I use, if it length 16 meter, okay, if I use the basic formula, then buckling load PB equal to pi square EI by L effective square equal to pi square into E. E is 210 to the power 3 into I is 10.831 10 to the power 6 divided by L effective is 16,000 square. Answer will come in Newton, but convert to kilonewton. See, answer comes in Newton, but therefore you get the answer first in newtons only, because why? Substitution is in newtons and millimeter, buckling load will come in Newton. You get in Newton, divide by 10 to the power 3, that is you get in kilonewton. Answer, fast. This is the load at which this maybe steel pipe of this dimension and effective length, how much? 16 meter will buckle. That is what load it will buckle. Pi square into 200 exponential 3 into 10.831 10 to the power 6 divided by 16 10 to the power 3 divided by 16 10 to the power 3. Oh, something went wrong here. Pi square into 200 exponential 3 into 10.831 10 to the power 6 divided by 16,000 square. Divided by 10 to the power 3. 83.514 kilonewton, correct? 83.514 kilonewton. 83.514 kilonewton. Make a note. Or, right here. Or, suppose you use modified formula. I am telling for some reason. Reason is there. Modified formula, then your buckling load PB equal to pi square EA by lambda square. So now you require lambda. Lambda equal to L effective by R minimum equal to 16,000 by minimum R is 49.6244. That is your lambda equal to, see, danger number. Lambda equal to unitless quantity. It is 16,000 divided by 49.6244. 322.422. 322.422. Correct answer? Lambda is 422. Is the lambda correct? Is the lambda correct? Okay. Or, remember, this is steel. In the IS 800, can you tell what is the maximum limit for lambda? Under normal loading condition for a steel column, IS code told there is a dangerous column. It will buckle very easily. Means very, very bad column. The maximum limit for lambda for steel, if you remember from IS code, how much? How much, tell me? If you remember IS code, they told under normal cases for a steel column, lambda should not exceed limit. Even though you will tell, I will apply very lesser load. They will still tell, nothing doing. That column by looking only looks dangerous. They will tell, you don't apply the load, but they will tell it's a column looks dangerous at the looking only column looks dangerous. Therefore, tell me the answer. If you remember from steel, the limit for lambda, upper limit for lambda, at any cost under normal loading case, special case limit, if you consider wind load, earthquake or separate, not 80, not 80, 80 is the usual lambda you get for RSJ sol. When you go for ISMB, etc., you get 80 lambda. Lambda comes 80. 80 is not a problem. 80 is not a problem. You forgot the number. In the steel, I told you, IS code told lambda should never exceed. Not 80. I think you forgot one number. It is not 80. Can you tell me? It is not 80. You can make a note. It is not 80 in steel. Forgot so fast. All steel forgotten. It is not 80. Why so much delay? It is not 80. 80 is usual. If you go for ISMB 300 or 400, when the height of the column is around 4-5 meter, 3-4 meter, lambda will come around 80. That is no problem. It can take what? Around 100 tons load it can take. It may take around 80-90 tons. Or a little bigger section. ISMB, if you go for 500, it can take more than 100 tons. 1000 kilonewton. That is not a problem. It is not 80. IS code told danger number they fixed. If you forgot, tell forgot it. I will tell you. If you forgot it, tell forgot it. I will tell you. Because little I know about steel also. You are not answering. See, today problem. No answer is coming. When requirement is there, you are not giving answer. Forgotten. It is 180. But don't mention here. This is strength of materials. So that only will tell you this is a dangerous column. Or according to IS code, this is a short column or very, very long column. Tell the answer. According to IS code, is it a short column or very, very long column? Now you can tell. They told more than 180 is ruled out. So then only you can make out 322. So this column, IS code will not permit you. So this column is a short column or very long column. It is a very, very long column. So this will fail by what? Buckling or crushing. Now only you can tell. This will almost fail by. Predominantly it will fail by. It will predominantly fail by what? Buckling or crushing. Buckling. So do you think this formula, this column, Euler's formula is applicable? Tell me. Therefore you are sure now. This is a danger column. It will buckle. So what is to the mind? Is Euler's formula applicable? No. Not applicable. What is this? Euler's formula is applicable only for long column which fails by buckling alone. Not applicable. What I can tell? If you tell that way, this is a very long column. The basic requirement of general formula. What general? Where I told general formula? Where I told general formula so far? I accept Euler's formula. I told nothing in the class so far. I do not know general formula now. As it comes, I will be knowing about it. As it comes, I will be knowing about it. Right now, I am not told. It is very much applicable. 1 minute. Wait for some time. Okay, now start. Substituting your Euler's buckling load, red color answer is what? Or I will substitute here. Euler's buckling load PB equal to pi square into 200 10 to the power 3 into area. Area is, area parallel. 4398.230 divided by 332.422 square. It will come in Newton. Therefore, if you go to modified formula, your buckling load will come. Tell me how much? By modified formula, your buckling load will come. It comes in Newton, convert to kilonewton. Tell the answer. If you go to modified formula, your buckling load will come. Red color I will write. See, black color for original formula, red color for modified formula. Answer should be same. How much? Buckling load. 83.514. Correct? Okay. 83.514. 514 kilonewton. Okay, now just okay, leave it. 83.514 kilonewton. Now I will come this side. I will remove all this. Start fresh one. So this I do not want now. See, this question I do not want. Okay, start. Now continue. This length I will remember. I told 16 already over. Next is 4.2. Next is 0.4. Leave it now. Okay, now. Start. Case 2. Your case 2 is your L effective length. See, this is not for time pass. Remember, L effective equal to, I told 4.2 meter. Okay. That is 4,200 millimeter. 200 millimeter. Therefore, here, if I use original formula, your buckling load PB equal to, what is formula? Pi square EI by, I am using only Euler, L effective square is pi square into 210 to the power 3 into I remains same. I is not a property of length, it is a property of cross section. So I will not change. I equal to 49.624 10 to the power 6 divided by L effective is 4200 square. This comes in Newton. Therefore, by original formula, as per original formula, buckling load comes in Newton, convert to kilonewton. How much answer? Tell fast. Don't make mistake. There's a reason. Don't make any mistake. No mistake. $5552.94. 1 to 1 1. How? Pi square into 200 10 to the power 3 into I is 49.624 10 to the power 6 equal to store A. Okay, then shift store A divided by 4200 square. I am getting 5552.94. 1 to 1 1. How? What is happening first of all? See, you are giving a wrong value, Anisha. Pi square into 200 10 to the power 3 into 49.624 10 to the power 6 divided by 4200 square. What? I don't know why you are making mistake like this. How it is 1211.922? Oh, it is R. What is this? This is my mistake. Sorry. My mistake. When I looked there, wrong. Okay. It is correct. You are right. I is 10.831. Okay. The journey effect yesterday came by native place by driving a two-wheeler. So fully strained. The strain is still there. That's the reason. One day morning to evening driving by two-wheeler is not a joke. This age. Square into 200 exponential 3 into 10.831 10 to the power 6 equal to store A divided by 4200 square. 1211.991, or shall I put 1212 kilonewton? 0.99 I want to sacrifice. Later I will put this as 83.5 kilonewton. Okay, 83.5 kilonewton. Why leave it? First decimal is sufficient. Here, shall I put 1211.99 as 121 first decimal answer? Why? Comparison. Shall I put 1212 kilonewton? 1212 kilonewton. Agreed? 1212, because I will round off to first decimal. Why? Because discussion required. Who will bother about the decimals today? Okay, 1212 kilometer. Or if you use the modified version or real practical, see, modified is real practical knowledge, then your buckling load PB equal to pi square EA by lambda square. So therefore, now you require lambda. Lambda equal to L effective 4200 divided by R 49.624. What is the lambda? Tell me. Lambda 4200 divided by 49.624. Lambda equal to 84.6364. 6364 lambda. Oh, I want red color for lambda. Therefore, your lambda equal to 84.6364. There's a reason for red color. This is a lambda. This is a normal case. If you use usually ISMB section, lambda for a length of 4.5 effective length, lambda comes around 80, 90. It is a normal case. So IS code will tell no problem. This is a reasonable case. This is reasonable case. That means okay. Or now, if you substitute, your buckling load will come pi square into E, 210 to the power 3 into I is 10.831 10 to the power 6 divided by 84.6364 square. Now also tell what is the value of Euler's buckling load by this one. It will come same answer. How much? 1212 kilonewton. Okay, correct? Clear now? Clear or not? Fast. Concept fully clear? Concept fully clear? If fully clear, I will go to last case. Last case, you can see horrible feeling will come. Then only you will understand limitations of Euler's formula. See, then only you will understand. If not today, tomorrow I will extend it. Don't worry. Because it's a principle. It is not for time pass. Is the concept clear so far? See, Is the concept clear? Impossible. You cannot get that way. How possible? Ayyo. Pi square EA, not I here. Area comes here. 4398.230. See, print mistake. Now check it. Print mistake. First formula I comes. Second formula I is there in denominator in the form of 1 by R. So area to be written. Print mistake. Sir, for case 1 now. Anything wrong there? How possible? Pi square into 210 to the power 3 into 4398.230 divided by 332.422 square. 78. Then something wrong. I don't see. If this is the way you give the answer, what I can do? My class is going to be spoilt now. See, such a serious class, it is going to be spoilt. I don't know what happened. It is going to be spoilt. See, such things should not happen, first of all. There is no excuse for this one. 10.831 10 to the power 6 divided by area is 4398.23 equal to root answer 49.6244. Pi square into 210 to the power 3 into 10.831 10 to the power 6 divided by 16,000 is 83.5 kilonewton. Okay, second one. 16,000 divided by 49.6244. Lambda is 16,000 divided by 49.6244 is 322.422. So pi square into 210 to the power 3 into area is 4398.23 by lambda square. It is 322. Print mistake here. See, you are first of all not observing. It is 322. 322.422 square. How it is possible? 322, print mistake. See, you are not observing. See, if you don't involve yourself in the calculation, see, when I write the answer, you should tell immediately, not tallying. I see, first of all, I never got any shock. I know some calculation problem or print mistake. In my class, only chance is print mistake. In my class, when I tell answer has to come same, if answer is not coming, only chance is either calculation mistake or observation mistake, writing value or writing print mistake. Other thing is technical mistake is ruled out. I told here, you know it. Okay, you know it. Technical mistake is, first of all, someone will tell, this person thinks too much of himself. Yes, I think that way. Why should I hide it? I know it. Technical mistake ruled out. I told it is ruled out. It is impossible that I make a blunder in technical concept. Tomorrow come and tell, sorry, last time I told least value, sorry, take higher value. Last time I told you have to add it. Sorry, you should not add, you have to multiply or subtract, etc. If I tell that way, that's the end of my teaching. If I tell anything like that, that is the end of my teaching. I will not take one more class. I have never cut sorry figure early so far. Okay. Now, answer same or not? Here, 1 2 1 2, correct or not here? Tell me, this question. 1 2 1 2, correct? Now, the second example. Now see, lot of time is wasted. Second example, second case. 1 2 1 2, correct? Second example, 1 2 1 2, correct or not? First, you are correct. Okay. Now, very important. Come to the law. I will remove this formula because I want to cover everything. Now, see. Come to case 3. Remember, some will tell He took a class, entire class he wasted by telling repeated. No, I am telling some concept also. Discussion, if you want, you can make tomorrow, no problem. Third case is effective length. That is L effective equal to how much I told? I want a short column, some 10 inches. Yes. 0.4 meter. Yes or no? I told 0.4 meter. Tell yes or no. First, I forgot. I remember 10 inches I told. Is a 0.4 meter correct? Now I don't want to change. No one should tell later. First he told 0.3. Now he is telling 0.4. First he told 0.3. Now he is telling 0.4. I remember 0.4. Why? I told length may be 10 inches. That is what? 200 millimeter. Double is 400. Double you don't bother. Correct? 0.4 correct? Okay, start. Now, 0.4 meter is 400 millimeter. Now, see, now do one thing. Basic formula apply. Get the buckling load. By what formula? Pi square EI by L effective square. Okay, then apply modified formula. If you use modified formula, you take buckling load PB equal to pi square EA by lambda square. Lambda you have to calculate L effective by R minimum. Calculate, substitute. Okay, I'll take non-stop talking, not much. 2-3 minutes break. Can you give the answer for both? Can you try now? No. Can you try? Change the effect length to 0.4 meter. Can you try? Tell yes fast. Yes, start. Not waste much time. Just 3-4 minutes. Small break for me because talking non-stop is difficult. But concept is going to come today. Remember, powerful concept is going to come today only. Otherwise, I can do recording for this one. If only this much is there, recording also will do. Okay, just 2-3 minutes. Not much. Okay. I heard a news. What is the catch? See, I am not bothered to calculate. I wrote outrightly, impossible. I wrote outrightly, impossible. Means I am so sure. No. And then I got the reply. I am not commenting that getting the same answer once again. I told 100% not possible. Such things if I tell, I stick to it. Now if I find that your answer is correct, then I am losing my face. Okay, let me see what is happening. See now, not what is the catch. See, equal to pi square into 200 10 to the power 3 into I is, where is I? 10.831 10 to the power 6 divided by 400 square. It comes in Newton. Tell the value in kilonewton. I will tell you later why I am so sure. I told impossible. See, I first told impossible. Then when the reply came, I am getting same answer once again. I told 100% not possible. Question came, what is the catch? No catch. Catch I will tell you most probably because of the little time wasted today, because in the beginning you delayed around 10 minutes you delayed, and in between some mistakes are there, not mistake, print mistake was there, little time wasted. I cannot discuss the concept in a hurry. Okay, but I will give all the values today, so that tomorrow when I take up, I will take only numerical values. Now tell the answer. Now tell the answer. Let me see. I will take my calculator now. If same answer comes, I am going to throw this I am going to apply a bending moment of around, I will calculate, 20 kilogram meter. This will break then. Okay. Let me see. Pi square into 210 to the power 3 into 10.831 10 to the power 6 divided by 400 square. Yo, what is this number? 133,622.1 kilonewton. I think to convert Newton to kilonewton, you divide by 10 to the power 6, I think. Yes or no? Tell frankly. To convert Newton to kilonewton, most probably you divide by 10 to the power 6, I think. Tell me yes or no. It happens sometimes. No catch. See, I told you, impossible. I got a shock actually. You divided by 10 to the power 6 to convert Newton to kilonewton. Tell me yes or no, frankly, because your number is tallying. Your number is tallying. In a hurry, you divide by 10 to the power 6. Tell frankly, yes or no. Tell frankly, yes or no. Divide by 10 to the power 6. No, no answer. I think that's what mistake you made. When I got the number 133,622.1, I suddenly came to know that you made conversion mistake. Of course, very simple, but be careful. Such mistakes in the result, final result means people can make out. When you find area of steel, suppose 3 number misses or number of bars. Instead of getting 3 bars, if you get 300 bars or 0.3 bars, you can make out, oh, something wrong. But if this value is somewhere else in between, and later when you get the result, if you get odd value, then you will not be able to know what is the mistake. So since it is the final answer, okay, you can make out. See, but if it is the intermediate value and then you are going somewhere else, then such mistakes are done. You should be extremely careful. It is a dangerous mistake. Clear? Here, final result. Okay, now leave it. Okay, leave it now. Now, L effective equal to 400 divided by R. Where is R? 49.6244. Lambda, how much lambda? Lambda equal to 400 divided by 49.6244 is 8.0606. Therefore, your modified formula PB, if you use modified, it will become pi square into both are same formula. E is 210 to the power 3 into area is 4398.230 divided by 8.0606 whole square. 100% your buckling load will come. Same answer. Hey, same come same. 133,622.1 kilonewton. Red color is modified formula. Now later I am changing red color. This is color. Color is for original one. Tallying answer. Tallying or not? Fast. Tallying or not? Fast, tell me. Tallying or not? It has to tally because this is not a new formula. Same formula modified. It is only interchanging of some terms. Therefore, both the formula is same. Tallying, okay. Now, make a note now. See. Okay. I will now do one thing. I will write here result. Okay. See. I will put the result. Very important. I will put in the corner. So, your cross section is hollow circular section made up of steel. Okay, I will take now. It is a steel. You take from me. I am telling now it is steel. Steel. For steel, I told crushing stress. Crushing stress. That is sigma CR equal to, I already told you, 330 Newton per mm square. Actually, MPa given. Okay. MPa is Newton per mm square. Okay. This data, did you use so far? Tell me. Did you use so far this data? This crushing stress data, did you use so far? This is the important concept now. The concept will start now. Okay, time getting over. First tell me, did you use this data so far? Did you use this data 330 Newton per mm square? Did you use so far? When you applied Euler's formula, did this sigma CR used or not used? You are not answering. See, I don't know why such so much delay. This delay only is costing me a lot of time. Not replying. Again confirming audio. I am just confirming audio. Not used. Okay, done. Now, remember, its cross-sectional area A equal to how much? 4398.230 mm square. Therefore, forget Euler. Forget Euler. Oh, okay, not forget Euler. Leave it now. And it's I equal to what? Least I. I minimum equal to 10.831. 10.831 10 to the power 6 millimeter power 4, and its R minimum is how much? 49.6244 millimeter. Now, what happens is when L effective is case 1, your case 1, L effective is first time it was 16 meter. 16 meter. You got Euler's buckling load. Euler's buckling load, that is PB. First time you got answer of 83.5 kilonewton. This is the answer you got. Yes or no? You forget whether you use original formula or modified formula. You got the answer 83.5 kilonewton. Remember, at that time, your lambda was 322.422. Tell me yes or no. Your lambda was 322.422. Tell yes or no, lambda. I just want a yes or no here. At that time, I just want answer, yes or. If you delay, my next class will be delayed. That's why. Little rest I want. I am noting down important points, that's all. I am noting down only important result now. Calculation part I am not bothered. Tell me yes or no. Yes, okay. Now, this is the answer. And you write here. Later, if I apply Rankine's formula, the failure load, my symbol is PF. That will come right now. You believe me. Right now you believe me. Because tomorrow we are going to Rankine's formula. Right now you believe me. How I got, you never bother. How I got that answer, you never bother now. Where is the area? Where is that area? Area beda? 4398.23 into 330 equal divide by 1 10 to the power 3. 1461. Store A. Okay. Shift store A equal to reciprocal plus buckling load how much? 83.5. Reciprocal equal to 78 point. You will get 78.95 or 79 kilonewton. First decimal. You will get this. You will get tomorrow. Later means tomorrow you will get. Don't bother today. Tomorrow you will get 79.0 kilonewton. Okay, leave it now. Today this portion today you do not bother. It will come later. Okay, then. Whereas my case 2, when I change the effective length to how much? 4 meter. 4, forgot. Was it 4 meter? You forgot now. What was the effective length second time? Who remember it now? 4, not 4 meter. Second time, I rubbed it somewhere. Effective length second time was how much? Oh, who will remember it? What was the effective length second time I had taken? 16 meter. Second time. Some decimal I had taken, I think. Not exactly 4. 4.2 meter. Okay. I took effective length equal to 4.2 meter. At that time, your Euler's buckling load PB came. Is the answer? I rubbed it actually. Where is that answer? Oh, I fully rubbed it. Why should I calculate once again? Anybody can tell the answer? Second time came 1000. Answer. Euler's buckling load came 1000. How much answer? Tell me. Somewhere I had searched it. 1212 kilonewton. Correct? 1212 kilonewton. Correct? 1212. Is 1212 correct? 1212.0. 12.0 kilonewton came. And at that time, if you go to Rankine's formula, the value will come. Rankine value will be if wrong, I'll check once again tomorrow. 660.5 kilonewton will come tomorrow. Second word you don't bother. And at that time, your slenderness ratio lambda came. Your second question, lambda came 4200 divided by 49.624 is 84.6364. Okay. Then, and case number 3, When effective length changed over to 0.4 meter, just now you got your Euler's buckling load came abnormally high value, something unimaginable value. 1,33,622.1 kilonewton. Very, very high. And at that time, your Rankine's formula failure load will come. Your Rankine's failure load, that will come. One three 1435.8 kilonewton. 1435.8 kilonewton is the answer. This is you are getting tomorrow. Okay. And here your lambda came abnormally low value. Only lambda came. Where is lambda? 8.0606 came. Is this result fully clear now? On this basis, tomorrow I will discuss the applicability of Euler's formula and under what condition Euler's formula is applicable, what is the drawback of Euler's formula and how you can correct it, or what is the remedy for nonsense answer. See, this is utter nonsense. I will write here. This is utter nonsense. 1,33,622.1 kilonewton load, if this column can take, it is utter nonsense. But Euler will tell, according to my formula, this column will buckle at 1,33,622.1 kilonewton. That is nearly 13,362 tons. That is 13,000 tons. That is almost same as the column load for a building of, for a typical column load for a building of around ground plus 10 or 12. Now ground plus 13, 14. Ground plus 13, 14 building where load comes that much, this column will take the load. Euler will tell. You can tell Euler, what nonsense is this? That I will discuss tomorrow. So remember, tomorrow's class, very, very critical. Because I have to discuss now why it happened that way. See, you can make out when the length was effective at the 16 meter, you can see the difference is very, very small. This you worry tomorrow. Today you believe me. Today you believe me. The second side, 8 side. So you can make out the difference is not much high. Practically okay. Difference increased. Difference became abnormal here. This is reasonably okay. Nearby, quite 83.5. Rankine will tell 79. Okay. Practically okay. Second one, Euler tells 1200. Rankine tells 660. Hey Euler, what is this? Rankine is telling 660. You will tell, who is Rankine? You can tell Euler. Rankine is the one who gave formula applicable for any column that is practically accepted. So Rankine is realistic formula. So you can tell Euler, your first one is tallying somewhat reasonably okay. Second one, you are danger. You are telling double the Rankine's load. Third one, you tell Euler, hey, you get out. You are telling nonsense, or your answer is something horrible, unimaginable value. Euler, this is unimaginable value. These all I will tell tomorrow, why that way and what is the real concept. I will tell that way tomorrow. Agreed? So tomorrow's class very important. Agreed now? Okay. Okay, I will close. The one who is there for FPM class, he has left I think now. I will call and tell him, okay, I am starting now. Because right now FEM class is there, 9:15. I shift by 10 minutes more. Okay, agreed? Okay. Because already now 9:08. I will start around 9:20, 21, 22. Because around 50 minutes break I take usually. If I stop at 9 o'clock, I get 50 minutes break. So around 9:20, 9:22, I will start FEM class. Okay, thank you. Okay. No, in the chat, number reduced. That's why. Sometimes this chat gives you wrong. Maybe other one left, I think, most probably. Okay, okay. Okay, you can leave now. I start in 15 minutes now, FEM class.